Welcome to Chemical Nomenclature for Covalent Compounds. In this video, we're going to be looking at covalent compounds, going from the name to the chemical formula, and going from the chemical formula to the name. So let's get into it. First things first, we need to define a covalent compound. And a covalent compound is characterized by a covalent bond between two nonmetals. And two nonmetals can be found on the periodic table by looking at the staircase, which separates the nonmetals on the right side of the staircase, on the right side here, from the metalloids and the metals over here. So a covalent compound is from two entities that are nonmetals, which are to the right of this staircase. Another important aspect of covalent compounds is the fact that they share electrons. And an example here is with the water molecule. And as you can see by this diagram, there is an obvious sharing of electrons. And this is because they're composed of two nonmetals, and for this reason, they have very similar electronegativities. This is unlike ionic substances, where the electronegativities vary drastically. That's an important note, and it's also important to note that although the nonmetals are on the right of the staircase, hydrogen can also participate in covalent bonding. It's a bit of an exception, so keep that in mind as well. Alright, next thing, we're going to be looking at the important prefixes to know before you look at covalent substances. And these prefixes are very important to name covalent substances. And I'll show you how to apply them. So say we have a hypothetical compound, maybe an X2Y3. And if we were to name this compound, we need to look at the number of atoms within the compound. For example, to make one compound of X2Y3, you require 2 atoms of X. So if we were to describe this compound, we would need the di prefix. So it would be something like di-X. Di-X. And if you were to have, if you look at this compound, you would need 3 Y atoms to produce one whole compound. So we need to use the tri. Something like tri-Y. And obviously this is just a hypothetical situation. But the idea and the pattern here remains the same. What you have to do is identify the number of atoms that are constituent of a compound, and then make that association with the appropriate prefix. Awesome. So now let's look into some examples. So now we're going to be going from the chemical formula to the name. And there are 3 main steps you need to take. First, you need to identify each of the elements within the chemical formula and write them out. Then, when you're writing the second element, you have to add an ide-ending to the second element. And then finally, you get to look at the subscripts and use the appropriate prefixes. And all these 3 steps can be combined into one step, but for the sake of simplicity, we're listing them out. Okay, so now let's get into some examples. But before we do that, there is an important rule that we need to look at. And it's the fact that the mono prefix for 1 only applies to the second element. For example, if we were to have CO2, it's carbon dioxide. It's not mono carbon dioxide. Whenever there's only one of the first element, mono is not applied. It's only applied to the second element. And it's just one of those things in chemistry, because mono carbon dioxide sounds a bit weird. It's just carbon dioxide. And we'll see that in the examples. So first things first, here we see this example, PCl5. You know that P is going to stand for phosphorus. Let's write that out. Phosphorus. And you know that there's going to be chlorine, so chlorine. So you're going to have chlorine. But as you see over here, the second step, when you write the second element, you have to add an IDE ending. So it's going to be chloride. All right. Now, let's look at the subscripts and use the appropriate prefixes. There's only one of phosphorus. And as we mentioned with this really important rule over here, you don't need to add a mono. It's just phosphorus. Okay. And there's 5 chlorine atoms. And if we look at our table up here, 5 is associated with the prefix penta. So if we add that prefix, it's not going to be the same line, but just assume that it is penta, and then you can just finish it off with chloride. So the overall name of this compound is phosphorus pentachloride. Okay, from now on, we're going to be doing all of the 3 steps in one step. So you see here, you have SO2. You're going to have a sulfur, and you're going to have oxygen. There's 2 oxygens. So you're going to need the di prefix, and you're also going to need to add an ide ending to the oxygen, which is going to make it oxide. So we're going to have sulfur. And then since it's going to be 2, you're going to have di, and then ide ending, so oxide. prefix, ending. That's the name of the compound, sulfur dioxide. Awesome. Next, we're going to see that there's nitrogen and oxygen, and there's two nitrogens, di, which is the appropriate prefix. It's going to be dinitrogen. There is no specific ending to the first compounds, the first part of it, so don't trip that up. So dinitrogen, and there's going to be 5 oxygens, and 5 is associated with penta, right? And then you're going to have the ide ending, so it's going to be pentaoxide. So pentoxide. And it's not pentaoxide, it's pentoxide because the 2 vowels there. So it's just going to be pentoxide. Awesome. Let's go on to the next one. We have Si2Br6. Si is a bit of a less seen element. It's silicon. So there's going to be 2 of those. So we're going to have the di prefix. So it's going to be disilicon. Disilicon. And then we see bromine over here. And there's 6 bromine. If we look at our table over here, we see that there's going to be a hexa prefix. All right, so let's write it down. So you have a hexa prefix. Hexa. And then it's going to be BRO, brom, and then we're going to have an IDE ending. So just bromide, right? The name of the compound is disilicon hexabromide. Final one, this one may trip you up a little bit. This is going to be CO. And as we can tell, this is going to be carbon. It's 1 carbon. And there's only 1 oxygen. Now remember, mono applies to second element. So in this instance, it's only 1 oxygen. So we're actually going to use that mono prefix. It's going to be carbon and then monoxide. Mono plus oxide is monoxide. Monoxide. Awesome. So hopefully that made sense. Okay, so now we're going to be going from the name to the chemical formula. And there's 2 steps in this process. First, we have to write out the symbol for each of the elements, and then use the prefixes to identify the appropriate subscripts. Again, you can totally do this in 1 step, but I just listed it as 2 for simplicity. So let's get into it. First things first, we're going to see that this compound has sulfur, and sulfur is represented by an S. And you see that there's going to be fluorine, which is fluoride here because of the IDE ending. So kind of subtract the IDE ending and add the original ending to identify the element. So we're going to have S and F. Next, we can look at the prefixes to identify the appropriate subscripts. So there's going to be only 1 sulfur, and there's no point in writing a 1 here because that's never really done. The presence of the S alone implies that there's going to be at least 1 sulfur. So the 1 here is redundant and you're never going to see it. But on the other hand, there's 4 here because of the tetra prefix. We know that corresponds to 4, as we saw in the table over here. So we're going to have SF4. That's the name of the compound here. All right. Now this next one is dihydrogen monoxide. The di prefix corresponds to 2, and there's hydrogen here. So it's pretty safe to say that we have 2 hydrogens, right? Then we can see mono, which implies that there'll only be 1 of something, and then oxide, which implies oxygen. So it's going to write 1 oxygen. And this is water. So if you want a cool way to say water, it's always dihydrogen monoxide. All right, next one. We're going to have selenium hexafluoride. Okay, so we see selenium, and this is the less common element, and it's abbreviated by Se. There's only 1 selenium, as there's no prefix here. And there's going to be hexafluoride. And if you go back to our table, hexa corresponds with number 6. So we're going to see fluoride, which is going to be fluorine. So it's going to be SeF. And the hexa corresponds with 6 of these. So SeF6. Awesome. Final one. This one's a bit long, but in difficulty, it's the same as the other ones. So we see that there's a phosphorus, plain as day. And you see tetra. Tetra is associated with 4. So you see P for phosphorus, and there's 4 of them. So P, there's going to be a 4 there. And you see sulfide, which corresponds to sulfur. And that's abbreviated with an S. And the prefix here is penta. Penta corresponds with a 5. So it's going to be P4, S5, and that's the chemical formula. Okay, in this video, you looked at the covalent compound, what a covalent compound actually is, the prefixes, and we converted from the chemical formula to the name, and the name to the chemical formula. Please like and subscribe, and I hope to see you guys soon.